Today our topic is triangle congruence by SAS/HL, which means side, angle, side, and hypotenuse leg. And our essential question is, how can I prove triangles are congruent using the sides and angles? Alright, first off we have postulate number 20, which is side, angle, side congruence postulate. It states if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. So what it means is the included angle, we really have to focus in on that word included angle, which means it's in between the two sides that are congruent. So if you look, we have this side, RS is congruent to this side, UV. And then RT is congruent to UW, and then the angle that's between them is congruent. So we use side, angle, side. For reasoning, down here we have decide whether enough information is given to prove that the triangles are congruent using side, angle, side congruence postulate. So if we look at our triangles, here we have this side, AD is congruent to BC, and then they share this side, DB. However, the angle is not included in between the two sides that are congruent. We would need to know that this angle is congruent to this angle. So based off of this diagram, no, we do not have enough information to prove that the triangles are congruent. Here, if we look on the second example, we have LM is congruent to NQ. MN is congruent to QP, and then two right angles are congruent to each other, the two sides, and then the included angle. So yes, we do have enough information to use side, angle, side. Write a proof. If we are given that BC is congruent to DA and BC is parallel to AD, we want to prove that triangle ABC is congruent to triangle CDA. So set up your two columns, statement, reason. Statement 1 should always be your given. So we have BC is congruent to DA and BC is parallel to AD, reason 1. That is our given. Now, if we look at our diagram, we have BC is congruent to AD. Well, we have one of the sides. We also know that AC is going to be congruent to itself by the reflexive property. So that is the other side that is congruent on the triangles, which means we need the included angle to prove by side, angle, side. We need to be able to say that this angle right here, angle CAD, is congruent to this angle, angle BCA. Now, if we think back to last chapter, Unit 3, we have parallel lines right here cut by a transversal. So if we think they're on the interior and this angle is on the opposite side of this angle, so they are alternate interior angles. So when we are listing out the reasons, if we're using side, angle, side, we need to list out the reasons: a side, an angle, and then a side. In our given, we had the first side, BC is congruent to DA, so our second reason needs to be the angle. So we can say that angle BCA is congruent to angle CAD, and the reason being is the alternate interior angles theorem. So like I said, everything from previous chapters we will continue to use as we move forward, so we want to make sure we're not forgetting things from previous units as we move forward. The third reason will be our other side being congruent to itself, so we would say that CA is congruent to CA, and that is by the reflexive property of congruent segments. And then lastly, since we've listed out that two sides are congruent, two angles are congruent, and two sides are congruent, and the angle is in between the two sides, we can say that triangle ABC is congruent to triangle CDA, reason being side, angle, side postulate. All right. In general, if you know the lengths of two sides and the measure of an angle that is not included between them, you can create two different triangles. So if we look, we have the two sides here, and then the angle is not in between them, like we work with for side, angle, side. Therefore, we can say that side-side angle is not a valid method for proving that triangles are congruent, although there is a special case for right triangles. If you look at side-side angle, read that word backwards. And just know we don't use that word in math class, so we don't use that word for triangle congruence. So if you're ever thinking about your triangle congruence, postulates, and theorems, know that we do not use side-side angle, because if you read it backwards, you have your answer. Theorem 4.5 is hypotenuse leg congruence theorem. So this is our special case for right triangles. If the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of a second right triangle, then the two triangles are congruent. Now this is the only time that side-side angle works, and it's only for right triangles, which is why we call it the hypotenuse leg, because those are our terms for right triangles. So as long as we know a hypotenuse and a leg of a right triangle are congruent, then we can say the two right triangles are congruent. So we want to write a proof for this. So we want to draw our two columns, statements, reasons. So in the diagram that we are given, we're told that WY is congruent to XZ. WZ is perpendicular to ZY, and XY is perpendicular to ZY. So the perpendicular pieces give us these right angles. Now, if you're ever given overlapping drawings, a really good strategy is to unoverlap them, so separate them so that they are two distinct triangles, and orient them so that they look the same. So I've done that for you. I've redrawn the triangles, I've reoriented things, and given you that information that is necessary. So ZY is congruent to itself, so that's why these two are congruent. Then we were told that WY is congruent to XZ, so that's where we get these. And then the perpendicular pieces give us these right angles. So really we were given all the information that we need. All we have to do is say, one, WY is congruent to XZ, and then WZ is perpendicular to ZY, XY is perpendicular to ZY. Our reason would be that it's given. Then we can state that ZY is congruent to ZY by itself, because that's that reflexive property. And then the next piece would be that we need to show that they are right angles. So we need to say that angle WZY is congruent to angle XYZ. And the reason being that is a consequence of perpendicular lines. So we can just actually use the definition of perpendicular segments. If they're both perpendicular, they're both right angles. So we can just use the definition of perpendicular segments. And then lastly, we can say that the two triangles are then congruent. So triangle WYZ is congruent to triangle XZY, and our reason for that is the hypotenuse leg congruence theorem. All right, that's all the notes I have for today. Thank you for watching this video, and please subscribe to my YouTube channel.